Hello. Take a look at this problem. It's a nice example here. Kind of leads us into why we're studying this in the first place. Okay, here we go. So suppose we have this profit, right? Suppose a total profit in hundreds of dollars from selling X items is given by this polynomial. You know, to complete part A through D below. Okay, so first we want to find the we're going to find the average rate of change of the profit as X changes from 3 to 5. Then we're going to find the average rate of change of the profit as X changes from 3 to 4. Then we're going to find find and interpret the instantaneous rate of change of the profit with respect to the number of items produced when X equals 3. And this number we need to know is called the marginal profit at X equals 3. Okay, I drew this picture, and this is totally out of scale, but I want you to realize what's going on here. Okay, so we have this situation. Let me bring up my calculator. I actually calculated some of these things here. Okay, so here we go. What you're looking at, and I'll write this down. So this thing that we're calculating, this average rate here. So we're going to try to calculate P of 5 minus P of 4 divided by 5 minus 4. And I guess it would be ideal that you would realize this, and you should realize this in the future, is that this is the slope of a line. And in fact, I'll show you. I'm going to draw a line here. It's the slope of this line. Okay, let me get my little diagram out here. I mean, this is what you need to know, so shall we say. These exercises are to help you know what I'm talking about now. That if you calculate it, if you look at this line here, okay, this line has a slope equal to whatever this number is, okay? And so I use this calculator to show me that the slope of this line is 19, okay? And I simply calculated, you can see here, P of 5 is right there, right here, and then P of 5 minus P of 3. Oops. Yeah. Oh, I think. Oh, okay. I'm sorry. Here. See that 3? I made a little error here. Let's back up. This is actually, I'm going through the wrong points. This is P of 3. So the line is correct. I just didn't calculate at the right points. So this is a 3, not a 4. Okay, so if you calculate that, you get 19. Now the slope of that line is 19. Now the units here, it's given in the problem that the units are in terms of hundreds. So the answer to the first question would be find the average rate of change of the profit X as it changes from 3 to 5. That'd be 1900 dollars per item. Okay. Now the next question we're going to answer the same question from 3 to 4. Okay. So what changes there is the following. What changes is the picture, for example. We're going to be finding the slope of a different line, and that line that we're going to be finding the slope of will be this one. I'm not sort of drawing in there. You see the picture is accurate in the sense that the line has actually has a lesser slope. And so then we can get out, you would need to be able to do this by hand, of course, but I'm just to speed this up, we're going to calculate, let's call this M1 and M2. That'd be take the polynomial at the point 4, and then we subtract the value of the polynomial at the point 3, and we divide that by 4 minus 3. Okay, and now, so I did that, and what that corresponds to is you change your 5s to 4s, as I'm doing right now, including this one. And we see it's 16, right? So you see the average change in profit is less between those two intervals. It's actually 16, okay? $100 per item. Okay, now there's this notion of we're going to find and interpret the instantaneous rate of change of the profit with respect to the number of items produced at x equals 3. So what that's going to correspond to here is the following. I'll just draw a little picture here. Now, so the instantaneous one, we're going to be calculating the limit as these points get closer and closer. And what you may already know, or what we can see, or what we're going to discuss in the future, or however you want to think about that, is what we're really going to be finding then is the slope of this line here, and it's actually over this line right here, and that's basically the tangent line. So we're looking for the slope of that line right there. And our definition is the following. We are going to calculate the following limit. We're going to find the limit, right, as, let's say, the number a approaches, what number are we going to get close to? 3. Okay. We're going to take f of a, or p, our thing is p of a minus p of 3 divided by a minus 3. Okay, so what we're doing, you see here, is we're calculating this limit. We're seeing what the average rate of change is as we, for each of these lines, right, we let this point get closer and closer, and that limit is going to be called our instantaneous rate of change. Okay, so let's do that. Let's find out, let's actually find out what that is. So I get, let's see, 3x squared minus 5x plus 5. So this is going to be, first off, let me calculate this. P of a is 3a squared. I'm going to make sure I get the right function here. Okay, so it's 3a squared minus, then I'm taking 5a. And then what am I doing here? Okay, I'm going to be adding 5. Right? And then I'm going to be subtracting. I'm going to do a real, that's P of A. Well, let's see, what's P of 3? P of 3 is, I'm going to use my calculator because I'm so lazy right now. Let's see, how do I do that? Well, let's just do it. Okay, so it's going to be, I'm just going to do the following. This is going to be the simplest way. I'll put a 0 here. A 0 here, a 0 there, and then I'm going to put, I'll just leave that as a, just going to delete that and put a 1, okay? And then I put a plus sign there. Okay, so what I'm calculating now is, notice this is 0 plus, and this is P of 3, right? It's 3 times 3 squared minus 5 times 3 plus 5, so it's 17. Okay, so that is going to be 17, okay? So now let's see what we get here. So if I calculate, let's see, so 3a squared minus 5a, now if I take plus 5, and if I subtract 17, and I want to divide that by a minus 3. Okay, let's see what we get here. And this is the thing that we're going to calculate the limit of here. So it's 3a squared minus 5a plus, oh, it's actually, I'm sorry, this is going to be minus 12, right? Okay. So it's going to be minus 12 now, all over a minus 3, and we're curious, we'd like to know what the limit as a approaches 3 of this is. Now notice that everything is apparently fine, because if you plug 3 into the expression on the top, I believe you're going to get 0, and if you plug 3 into the expression on the bottom, you get 0. So there's a chance that this limit actually exists, and in fact it does. But let's see how we calculate that. Well, as usual, what we do is a little bit of algebra first. And what do we see? I'll bet you the numerator factors. In fact, I will bet my life that the numerator factors. So we get, I'm just going to put down a minus 3, because, and let's see, we must get 3a plus 4. Let's see if this is actually correct. I'm I'm just writing this down because I know it has to be correct in the sense that I know there's a factor of a minus 3 in the numerator of this polynomial. So let's see, and that's because of other reasons. Let's see if it's correct. If I take a times 3a, let's check it out. See, a times 3a definitely gives me 3a squared here, right? Now if I take 4a minus 9a, that definitely gives me minus 5a. So these two terms are correct. And minus 3 times 4 gives me minus 12. Okay, so it's correct. The numerator did factor, and in fact, what we see is that we get the limit as a approaches 3 of just this 3a plus 4, and so what we get, that's just going to be equal to, we plug 3 in there, so approaches. So you get 9 plus 4, and that's 13. Okay, great. So 13 is our instantaneous rate of change. All right, let's see what that means. Now let's interpret that per our question. It says, oops. Okay, so the question is, find the and interpret the instantaneous rate of change of profit with respect to the number x in items produced when x equals 3. So the answer is it's $1,300 per item, and I guess my interpretation would be that if the production rate were constant at this time, in other words, if it didn't change, right? And in fact, if our function p of x were not a quadratic as it is, but if it were a line, then our instantaneous rate of change of the production when x equals 3 would be this $1,300 per item, and that would not change. That's my interpretation. However, it does change, so it actually increases a little bit. Okay. What does this result mean? Choose the correct answer below. All right, let's see. A is when items are sold for blank dollars, the profit increases at a rate of $3 per item. No, that's crazy. When 3 items are sold, the profit decreases at a rate of, I could say something there, but I'm not going to. Let's say that's not correct. And in some sense, I could say when 3 items are sold, the profit decreases at a rate of negative 1,300 items dollars per item, because then it would make sense. But the one they're looking for is right here. It's set when 3 items are sold, the profit increases, right, at a rate of $1,300 per item. Okay, I'm trying to write. Oh, I'm using my thing here. $1,300 per item. Okay, well, I hope this helped. Oh, find the marginal profit at x equals 5. Okay, I will let you do that one as an exercise. It'll be very similar to the case when we found the instantaneous rate of change of the profit with respect to the number, right? So we calculate this, well, here, you would calculate this limit here, except if x is equal to 5, what you need to do is at the point x equals 5, then this here is going to be not a 3, right? But in fact, it would be a 5. So I'll let you do that one on your own there, and hopefully this helps you out. Thank you very much.